Okay, now let's talk about thermal rate. Thermal obviously means temperature, so now we're talking about heat moving. Key thing to understand is heat is always going to flow from a hot object to a cold object. It can never go the other way. It has to go that way. And what's going to happen is this one is going to lose heat. This one is going to gain heat until eventually they're in equilibrium. Equilibrium is that point where they've reached right in the middle. Now, for heat flow rate, again, usually for flow we're going to use Q, so we would use QH, and it's going to be nothing more than heat divided by time. So QH, where QV would be volume divided by time, QM would be mass divided by time. So remember, rate is time dependent. Right now, though, we're focused on heat divided by time. Now, units for this. Well, heat is a form of energy. So to be honest with you, any energy units will work. Now, in heat, though, there's two energy units we use a lot. A calorie. Now, most of us are familiar with calories from talking about them. A calorie is the amount of heat needed to raise 1 gram of water by 1 degree Celsius. That's the definition of a calorie. Calorie is actually a metric unit. Not most people don't realize that, but it actually is a metric unit. So an SI unit for heat flow could be calories per second. It could also be joules per second, since heat's a form of energy. Either one of those would work. Now, the English system brings up a unit that you may have seen before, and that's the BTU. BTU is the British thermal unit. The British thermal unit is the amount of heat required to raise 1 pound of water by 1 Fahrenheit degree. So that's the thing. So BTUs is a common thing. Most common place we see BTUs, air conditioners. They will tell you how many BTUs it will put out. What they're usually quoting is BTUs per hour. So that would be an English unit of this. Now, I don't think you're going to necessarily do a lot of math with this. It's more an understanding. As long as you can understand that heat has to flow from hot to cold, as long as you understand that heat is really just a form of energy. And guys, if you think about it, let's put two things together. Let's go a little bit deeper in detail with this. So I'm going to take an ice cube, and I'm going to put it in water. And let's say the water is 20 degrees Celsius. The ice is 0 degrees Celsius. What's going to happen if I look at it even more blown up than that? Let's look at the side of the ice cube and this is the liquid water over here. What's going to happen is these molecules are moving. They're moving in all sorts of different directions. Well, what's going to happen is some of those molecules are going to collide with that side. As they collide with that side, they're going to cause this ice molecule here to vibrate a little bit. So what they're going to do is give the ice molecule energy. When they've given that ice molecule enough energy, if it gets enough energy, it eventually becomes a liquid. So what's going to happen eventually with your thing of water is the ice cube is going to melt, and this is going to go down to maybe 19 degrees Celsius. So in other words, it's going to change by a little bit. Now, how much ice you have in there is going to determine how low the temperature gets. Remember, heat always flows from hot to cold, never goes the other direction. And heat flow rate is nothing more than the amount of heat lost per time Or heat gain for time. Again, you put on a jacket to slow down your heat loss. That's the reason you wear a jacket in the winter. It's your own heat that's keeping you warm. Same thing with a blanket on your bed. All it does is trap your own heat in and not let it escape. Think about it. Over the summer when it's really hot, what do? You kick off the blanket, you kick off the sheets, and stuff like that to make yourself cooler. Hope this helped.